We're joined today by Flavio. And if you speak Portuguese, you have probably seen Flavio around in the machine learning communities that are going on in Brazil. There's a great machine learning Slack channel, Data Hackers, and Flavio's super active on there. And he reached out to us and said he could give a talk today or just have a chat with us. And before we jump into this high stakes ML that we came for, Flavio, I wanted to start off by getting a bit of background information from you. I know you're originally from Brazil. You're living in Berlin right now. Can you let us know how you made that transition, and then also what got you into computers and what got you into machine learning?
Yeah, so thanks for having me. Thanks for everyone for your time. Basically, my background it's a kind of accidental in terms of how I ended up in machine learning. So I used to work. I was in the military services for 7 years in a row. So I was corporal for a long time. And after that, I completed my studies in information systems. And after that, I started to work with several different technologies like SAP, Microsoft CRM, and so on. But I discovered that data for me was a brand new word. This was in 2011, 2012. And I started to make a transition. And after this point of the time to work with the SAP, I worked in a hedge fund, so that I used to make some kind of traditional business intelligence in credit derivatives, exotic derivatives, and so on. And during this period of time, I completed my master's degrees in computational intelligence that I used to build some predictive models for recovering credit assets, bad credit, junk bonds, and so on. And after this point of the time, I started to work a little bit more with machine learning. This was in 2013, 2014. I started as a data scientist originally, and after some point of the time, I used to go to some talks, and I saw that at least in machine learning, we are going to have a very huge impact. It's kind of different from traditional analytics, traditional BI, that you're just doing some kind of reporting or talking about the past, but actually you're doing predictions. So especially about the future, of course, but doing some kind of automated decisions. So, and I saw that after some small trips in Silicon Valley, and since then I started to work with machine learning from full time. Since 2015, 2016, and I ended up here in Berlin after receiving one invite for a company here, and to work as a data engineer to give some kind of support for data science team. But after some point of time, of course, that MyHammer started a new project, very greenfield project to power their applications using machine learning. So basically, this is the whole trajectory.
Cool. And can you let us know real quick, what does MyHammer do, and what is your day-to-day like?
Yeah, exactly. MyHammer is a marketplace that put together tradesmen and the consumers. So basically, we have several different kind of services. Things if you, for example, damage your car and you need to put some repair and bumps, or for example, carpentering services or plumbing, or some kind of roofing services, and so on. So we have more than 200 different services right now that we connect tradesmen that here in Germany require some kind of special licenses with the consumers. So, for example, if you have some kind of problem in your pipe at your home, basically you just open a new job inside of MyHammer, and some craftsmen are going to enter in contact with you to solve your problem. Basically, it's that. And basically, right now in MyHammer, as we are dealing in marketplaces that connects two different sides of the supply and demand. Let's put it that way. We use a lot of recommender systems, matching, especially matching. And right now we are currently working in some other allocation models that takes in consideration this kind of stable marriage algorithm to make the allocations for all the S business out of the platform. Basically, it's that. And my daily, my work day, I think it's 50% related with machine learning operations like checking models, checking drift, check if or metrics, I mean, special application metrics are okay or not. And for the other 50% of the time, I used to develop new ideas to try to optimize other parts of our marketplace, especially for the matching and recommendation. So basically, it's that.
Perfect. All right. So before we get into these Swiss cheese diagrams that you told me about before, what do you feel is the current state of machine learning systems? How do you see it right now and where we're at?
Yeah, I think we are. I think we are in some kind of turning point in terms of the applications of machine learning that we have today, comparing with the past, and seeing perspective that I see that there's some kind of march of regulation, very heavily regulation over the systems right now. So today I'm seeing that there's tons of new tools or new platforms that machine learning is easier to do than, for example, 5 years ago. So we have dot science, Databricks, several different platforms, Domino, Neptune, and so on. But we can see today that we still have this kind of this lack of professionalism, not professionalism, but some kind of amateurism in terms of how those machine learning applications are put in production right now. So and this, I mean, I make this conclusion based on several different communities that I participate, not only here in Germany, of course, but some communities in Brazil and in Finland also, because I have some family there. And it's super cool. Everyone is talking about machine learning, but when we discuss about, okay, how are you putting this machine learning system in production right now? So, and we can find the same problems like, no, we don't have a unified way to do some kind of unit testing, or we have tons of glue code inside of our code base. We don't have code review, and that there's some, and I put that in perspective with a very big march of regulation. So I wrote a piece about accountability and accountability in machine learning systems that, at least here in Europe, the most of regulators and governments are very well concerned about platforms doing decisions automatically. So it means that the era of a single guy with a single script inside of a machine, it's over. It's completely over right now. So if you're talking about some critical applications of machine learning, no matter what, inference, classification, time series, and so on, we need to have this workflow, this entire workflow completely in a more professional way, like software engineering. I mean, and I completely believe that machine learning operations would be the philosophy or the field that are going to put down this kind of hype and make the common ground with the regulators and all the stakeholders.
Yeah, that's a great point. And it's really interesting you talk about regulations being a driving factor. So I also, when we talked earlier, I thought it was super funny how you said there's a little bit of a lack of transparency when you look at different blog posts on MLOps right now, or you look at people explaining how they're putting things into production. Can you go into that a bit more in depth for us?
Yeah, exactly. I mean, it's kind of the way that I feel. It's that most of the things that are published right now in terms of machine learning suffers a very huge survivorship bias. You know, like we just see the shiny stories, like, okay, I implemented machine learning in my company and we earned $2,000 per minute or something like that, or we have the latest framework that solve all the problems of the universe, very shiny cases and so on. But as long as we just highlight these aspects, one thing that I think for me it's missing, it's that what's the story of the guys that failed, or what the stories of the guys that are right now in the trenches suffering to put those systems in production right now? Because as we discussed before, for every winner that we have, big tech companies, Airbnb, Uber, and so on, we have a very big trail of guys that did not survive. Like some death march projects in machine learning, or some kind of delusionments with machine learning, or teams that were completely fired, for example, or machine learning systems that were replaced with the rules and stuff like that. And my point is that it's super cool to see those posts in Hacker News or Medium blog posts or personal blog posts that, okay, so we put the system in production and so on. But one thing that I think it bothers me, and it's related with the high stakes machine learning talk that we are discussing right now, it's that let's study a little bit more about the bad cases, the cases that fail, or how those machine learning projects are suffering most, in terms of deployment. So how looks like your deployment? How looks like your code review? How looks like your data or code management or experiment tracking? So, and no one's discussed about this. Everyone discuss only about this a very bright side of all those new technologies. Of course, this is part of the hype, of course, but if you're talking about something that needs to take a little bit seriously in terms of put things in production that can be reliable in a certain way, we should discuss about the bad things also. So that's the way that I feel.
Yeah, I completely agree with you on that one. I mean, if we share our failures, then it gives an opportunity for everyone to learn from it. So
Yeah, absolutely. Yeah, absolutely. And at least for me, I mean, I just a quick story in terms of how I suffered. So in the beginning of my job at MyHammer, I used to train a classifier to do some kind of text classification, very bread and butter in German. So, and every time that we see some kind of NLP, so we see a lot of discussions between, for example, Yeshua Benjo, between Gary Marcus, Yulia Khan, and we see, oh, okay, so those guys are almost solving NLP. But when you go deep a little bit in terms of how the language are actually written in a very specific corpora, it's a completely different story. For example, one thing that no one told you, it's that, for example, when you see any kind of case of NLP, everyone just go to talk about, okay, so you guys need to use the stop words and so on and so on. But for us, it's theming or lemmatization. But in your case, using stop words, using lemmatization decreases at least between 3 and 5% of our text classifier. And we go deep to investigate. It's because, for example, some words there are considered stop words in some packages like Spacey, for instance, or in LTK. For us, are very specific words that can differentiate some services. You know what I mean? So it's not like a very straight forward when we see those blog posts and so on. So that's why I think it's very important to share your endeavors also in your journey.
perfect, of course. So pivoting a little bit, we talked about having a high standard and a standard of reliability. And you told me that you feel the aviation industry is the one to look at in that sense. And can you explain why you said that?
Yeah, exactly. So one thing, every time that we see some discussions about site reliability engineering or stuff like that for software engineering, we use it as a benchmark. For example, very big companies like Google, like Facebook, like Twitter, and so on. So it's super nice to check those stories of those guys, but those guys are not a benchmark of reliability ever. So, for instance, for example, and aviation, for example, last year we have 39 millions of flights. So during the 2019, for instance, and we had less than 290 fatalities during this whole year. And if we check the aviation industry, it's a case that as long as the aviation learns from the lessons of the bad things that occurs in the past, more reliable the aviation it is. So it means that we are talking about right now in systems, for example, one aircraft, in systems that critical systems needs to have a chance in a 10 billion to fail. So that's the level of reliability that we are talking about. Not, for example, a company that, for example, has some kind of policy like let's break stuff and move things and break stuff. It's not like that anymore. So, and especially when you need to make some kind of nomadic decisions that involves other human beings inside your platform. So you cannot have this kind of mindset. So you need to deliver reliability, and that's and if I need to define MLOps in a single word, for me at least it's reliability. So make those platforms reliable, not only in terms of the service level, but in terms of track the several different artifacts of the data and the code also.
Beautifully put. So we wanted to talk about risk assessment today, and I mentioned before that you have this Swiss cheese model. Can you get into what that is for us and how that plays out?
Yeah, exactly. So the story, the Swiss cheese model, it's a framework of risk assessment created by a guy called James Reason in the early 90s. And basically the whole idea behind of this framework is that for every system that we have, complex systems and accidents does not occur because one single factor. It occurs because at least six, not only six, but at least six different events that occurs in some kind of chain of events. And the point of the Swiss cheese is that for every barrier that you have, every defense layer, you can have holes. For example, one of the layers can be, for example, tech stack. And this can be one layer of this cheese. Another layer can be people, for example. Another layer can be, for example, processes. And for every one of these layers is a kind of barrier of defense, a layer of defense of those systems. And the holes of this of this layer, so that's why I call it Swiss cheese. It's some kind of vulnerabilities that you have inside of each layer. So, and those vulnerabilities can be latent conditions and active failures. And for example, let's say that we have a layer of tech stack, and one of whole of this layer of defense can be, for example, a framework that is not updated for the last 2 years, for example, some library. Another layer, for example, processes can be code review. So your company don't have a code review. So this will be one hole inside of this cheese. And the last layer, for instance, can be, for example, people. And you have a very big technical skill depth for the people that are actually doing the code. And for every event that you have in terms of outreach, it's not because of the skill of, for example, the last one of this skill depth that this person would have, but it's because of the alignment of the several different layers that, because some kind of casual aspect, get aligned. And because of that, you have this kind of event. So basically, this is the, in the very high level, the explanation in terms of this Swiss cheese model.
Yeah, and I think it makes complete sense, and it can be applied to any type of work. But how can we look at that within the machine learning context? I mean, I understand that you have these safeguards, and ideally they're foolproof. But in reality, what you're left with is safeguards that have problems with them. And then you have the perfect storm one day, and something makes its way all the way through each one of these safeguards. So how can we apply that to machine learning?
Yeah, so in terms of machine learning, so and if we want to apply this model in terms of risk assessment, we can divide between two different aspects. First one, latent conditions, and the second one, active failures. Latent conditions, it's that some kind of conditions that are inside of your system or inside of the processes or inside of the people, for example, that it's not some kind of thing that originates the failure itself, but some kind of dormant aspects that maybe this can lead a very ugly road along the line. So put in the simple terms, for example, I have this bottle in my hand right now, so in my hand right now. So basically, this is a glass of water, for example. And if I put inside of my table right now, I have one dormant condition because this glass of water is not moving. There's no activity inside of this bottle here. But if this glass of water here just, for example, just lay down here at my table, for example, this can break it up my laptop. And in terms of machine learning, so transposing this for machine learning can be, for instance, for example, if you have a lack of code review. So this is one dormant condition, so one latent conditions. One of the cases that I put in my blog post, so I will translate that for English until the end of this week. It's, for example, code review can be a very silly aspect to see that. But for example, one company called it Night Capital. In 2012, due to a lack of process of code review, one developer put a code in production 8 years outdated. So one code from, I think, 8 years outdated, I guess. And because of this, there's some kind of change of the logic inside this code. And due to that, this hedge fund, Night Capital, loses $172,000 per second per 45 minutes in a row. So it means that those guys lose more than $470 million due to some kind of code. Of course, it's not only that, but this is one of the contributing factors. Another contributing factor, for example, can be a lack of observability inside of the platform, for instance. So you don't have any kind of heart beating on your recommendation system, let's put that way. And your recommendation systems are not recommending nothing at all, or just recommending the same thing over and over, causing a bad experience for your customers, for example. So this is some very few examples of latent conditions in machine learning. In terms of active failures, it's some kind of action made by someone, for example, some system or human being, most of the time human beings, of course, that can be caused mostly by human factors. For example, skill depth, or for example, some code that was written that has tons of abstraction depth, for instance, or you put some tons of glue code inside of a code, and this is break some kind of data pipeline, and this can lead some kind of outrage, or basically you don't put any kind of observability, not logging, not monitoring at all, for example. So this is one of active failures. So when you let to do things, you know. So this is the main difference between these two concepts. And this can be transposed as well for machine learning. If I may, I would like to just share one slide for whom are watching us right now, but I will describe for the guys that are here and hearing in the podcast.
Perfect.
So hold on a second. I will share my screen right now. But basically, yeah. So can I share my screen?
Yeah.
Okay, cool. Let me just share. Okay, so and this is the slide. So basically, for who doesn't have the image right now, so I'm presenting right now the Swiss cheese of one example of outrage in machine learning system that we have 5 different layers. So one layer, it's architecture engineering. Another layer, it's a tech stack. So this can be one defense layer. The third one, procedures. The fourth can be engineering culture. And the last one, it's a people. And the outrage that I'm reflecting here, it's a conjunction of several different factors. that, for example, in terms of architecture engineering, for example, the latent condition here was the lack of monitoring and alerts, for instance. In the layer of tech stack, we have the whole in this layer, for example, that ML libraries. For example, if you put some, for example, Weka library, for example, that doesn't have any kind of improvement or whatever for the last 3 or 2 years. The third layer is procedures, and the latent factor here is that, for example, this can be a mix of active failure that glue code to do some kind of tech stack jungle when you have, for example, something being processed in bash script, and another part of pipeline is doing the Python, and the third part it's doing Scala, for example. So, and because of that, you lack some kind of procedures to avoid this kind of stack jungle. The next layer, it's about engineering culture, that we have this, the latent factor here, it's that lack of code or review culture. And the last one, it's the skill depth of some people. So this will be some kind of active failure, for example. And if we think a little bit deeper, for every kind of outrage that we have machine learning systems or outrage or in general, it's not only because a single factor, it's because one alignment, a perfect storm between several different layers. And the whole point of machine learning operations for me and MLOps for me, it's that to make those layers more robust, using tools and automation as well, for example. So this is one of the examples that we can transpose for machine learning.
Perfect. And I think now is a good chance for us to open up to the greater community here and see if there's any questions that anyone has. We'll take a second to pause and see if I see somebody talking right now in the chat. Tim, if you want to unmute yourself, you can go ahead and ask the question. Otherwise, I can say it.
Demetrius, just a thing. I will just share here in the chat the link for the presentation so everyone can check the slides and so on. So
perfect. Yeah, and I will also send this as a follow-up email to everyone and the recording of this talk. So Tim was saying, he's asking, are you able to talk about resume-driven development? Or
yeah,
resume. Yeah.
Yeah, resume-driven development. Yeah, of course. So this is one of the concepts. I think I heard that in 2012 and for some guy of Microsoft. It's that when some developers don't think about the architecture or the best solution for the company itself or the best solution for the application itself, but he thinks in the solution that can earn a plus line in their resume. So let me put some example of this. So in some point of the past, I used to work with Spark, so to do some machine learning in Spark, and basically one of the developers, this guy are very good in Scala. So but the problem is that the rest of the team used to work only Python. So it means that we had, for example, all this guy should adapt himself to Python, or all the other guys should learn Python, for example. And the consequence of that is that this guy made the whole data processing pipeline in Scala and just delivering the mesh data for the data scientists. And basically this guy earned, for example, oh, okay, yeah, this guy just put in his resume or his LinkedIn something. Oh yeah, I used to do tons of data engineering in Scala. But for the sake that every time that some of those data scientists or other data engineers that doesn't know Scala needs to make some kind of maintenance in the code base, for example, the whole maintenance took, for example, days or sprint, more than 2 or 3 sprints of 15 days, for example. Or most of the time, the code itself was not manageable at all. Another case, for example, was one guy that I used to work in the past, for example. Not I used to work with it directly, but it's some kind of side team or something like this. that this guy would like to learn about Elixir, like Elixir. So it's a very nice language. And basically, this guy put inside of the pipeline some ATL2 that use Elixir that reads spreadsheets from the Excel and puts that inside of the database. So it's not a bad thing, but if you want to learn something, so take that for you, or at least share this risk with your company and put the all the aspects involved in that, or don't do that, because otherwise, for example, when someone leaves the company, the code base can be completely unmanageable at all. So this is one of the examples of resume-driven development.
Yeah, perfect. Thank you for that. It's basically prioritizing number one over the greater team. And you talked about human, basically there's a lot of human factors that go into this. And can you go a bit deeper into that?
Yeah, absolutely. So one of the points that I see several different companies doing a very bad communication in terms of what DevOps is or what machine learning is. It's just about automation and remove the human factor on the loop. But I disagree with this vision, because if we start to think deeply, everything in terms, not only DevOps or machine learning, for everything in terms of software engineering, it's about the people itself. And why I'm telling that, it's that, for example, for you to include some kind of culture of automation inside of your company, you need to have, for example, some kind of influence of your organization to do that. So you need to have the environment for that. And environment are made of people. So if you want to, for example, to do some kind of orchestration of your services using, for example, Mesos or Airflow or whatever, or dot science, for instance, it's not about the tool itself. It's about, okay, so the person that have the knowledge to how to explore this tool, the maximum that can enhances the whole process, the whole ML process inside of the company itself. It's not only, for example, okay, so do the best script and that's over. So it's not like that. Everything is about the human factors in the end of the day. So, and not only, for example, in terms of the skills, but in terms of the environment, in terms of the culture. So this is a very important. And of course, for example, supervision, for example, this can be a very good example. For instance, if your team has some kind of if your team doesn't have some kind of a decision maker, for example, in terms of stack, like, okay, so let's decide, one example, machine learning. Let's decide right now what's the tool that we are going to use to do some kind of text classification. So if we don't have the decision maker, so this can be some kind of holacracy, that everyone has an opinion, and this can lead, for example, some kind of chaos inside the team. And this can lead to a problem. So that even with the best tools or all the automation that you want to have, the human factor at the end of the day would be the difference between the chaos and in terms of the reliability of your services. So there's no easy way out to get rid of humans, of course.
Yeah, completely. Thanks for painting the picture on that one. And in the spirit of transparency, I'm wondering if you have a story about when something that you were working on or at a different company you've been at got through all of these holes in the Swiss cheese model.
Yeah, exactly. This is a very a good point. So one story is that I mean, I cannot disclose the company and the person involved, but I was directly involved in the team. But basically, the problem was the whole problem was we had one outrage inside of our platform that we did not recommend anything for our customers for 17 days in a row. So it means that all the customers that accessed or recommendation system got the same the same services or the same catalog and over and over. So and because of that, we lose, I don't know, more than tens of dozens of thousands of euros for sure, because of that. But this is one of the points. So this is the whole problem, and this is what happens. And the one point that I include in my presentation is that, and I think this is a very good thing. Most people can think about this kind of latent factors or latent conditions or active failures, but some people can think, why not just fix the problem and move on? You know, like just fix the problem and move on. But the problem with this approach is that, for example, local fixes in some point of the time sounds very good, sounds very productive. And some companies have some kind of this concept of messiah, you know, like the company never faces some kind of outrage in their recommender systems or inside of your scoring platform. And we have only the savior that are going to enter inside of the machine and solve the problem itself and so on. And this sounds good, and this is nice, but the problem is that it's not transparent. So what's the root cause of this problem, you know? And the problem that I faced, for example, was we use this AWS ACS as a container tool for a container. But the problem is that the application, as we make the refresh of the applications, of the items during some period of time, due to some kind of increase of the size of the database, these containers got out of the memory. And because of that, we just use, and as we have this kind of promotion, so we just make the promotion after all the objects being refreshed. So we stayed with the same old objects and over. And the quick fix for that is just increase the limit size, you know, the memory limit, you know, like quite easy, super cool. So just double that and that's it. But if we go through, go through this problem itself, it's not only this memory problem. So the problem was why we choose ACS, because for example, was a very bad architecture decision. So we should go for another platform that we discussed, for example, Airflow and Kubernetes, that give us for grant some kind of aspects in that kind of problem. But this is another story. But this is one of the problems. The second one, the person that implemented this ACS solution didn't know how to work with the ACS before the project. So basically, this was actually the case of resume-driven development. So the guy just wanted to learn about this ECS solution and just implemented that. And the third factor is that we had one increase in terms of the volume of items, and this increase was because some kind of market campaigns that we made, and basically the people start to increase their demands for more products, and this is was some kind of active failure that occurred during this process, for example. And the fifth aspect, for example, can be the lack of observability. So we did have, for example, in that time, we had the application production, but we did have, for example, some heart beating to know some kind of application performance monitoring, for example, to check if we are dealing with the refreshed data. We did have, for example, logs to identify that. We didn't have any kind of alerts that, for example, can measure, that have some kind of measure, for example, okay, the diversity of items being recommended, for example, this can be a metric that we can monitor. So, and if we just think in a very simple way, was only the out of memory error in the ACS cluster. But as we can go deep, there are several different factors that align and created this perfect storm. And I think the main takeaway of this very bad situation that occurred to me, for example, it's that we should have a mindset not to garden problems or cultivate problems, but actually solve the problem. So instead to be driven to do only this kind of local fixes, like a very random fixing stuff. Have some kind of mentality of continuous reform, like see the specs that are increasing the latent factors that can lead active failures, and address them. So it can be by postmortem, can be inside of their sprint, no matter what. So, and the perfect analogy that I have for that is that instead to keep sweating against mosquitoes, like if you have some kind of mosquito problem at your home, instead to kill each mosquito once at a time, just go to the swamp and kill and just destroy the swamp where they breed. So you're going to solve the problem.
Yeah, thanks for sharing that. That is it's a great use case and a great explanation to show us how this actually happens in the real world and what repercussions it can have. So I'm going to open it up to the greater community and see if there's any questions there. And if not, I am going to keep on with my questions, but I see some people, let me see in the chat. So with all the challenges and risks and concepts addressed so far, can these can be found with software engineering. What new risks does machine learning bring to the table? That's a great question, Eduardo.
Yeah, I think Luke from the community, he make a very nice talk about the MLOps and the manifesto itself. I think there's some other challenges, like for example, in terms of the utilization of the data. Here in Europe, I mean, this cannot be applied by guys from the US or South America or other continents. But in Europe, for example, we are ruled by GDPR, for example. And I think it's the Recital 71, I guess, that regulates that the right of explanation. So every time that we make some kind of algorithm decision making for any platform that involves some kind of user, the user has the right to receive the explanation. So it means that, for example, in the old traditional software engineering, the thing that I just go to the ifs, see the rules, and then make the debugging and so on. But some data artifacts, some kind of machine learning models, for example, cannot bring this kind of explainability for you, for example. Like, let's say that you're using some text classification using PyTorch, using VGG16 architecture and so on. You train for, I don't know, 5,000 euros in 4, 5, or 6 GPUs, LinkedIn, and so on. So you cannot explain that. So you cannot use that, because if your company receives some kind of inquiry for this kind of right explanation, for instance, you are unable to do this. So this is one of the big challenges. The second point, I guess, I think it's the, I think outside, I think this is a part of the fault of the culture of data science that I see today, is that there's tons of very little hacks, tons of shortcuts in terms of the way that things are done, especially in production. And we are just putting these things in place and doing automatic decisions on top of that. But for example, and because of this very hacking culture, or not very well codified in terms of software engineering and practices, for instance, we can let happen, for example, mistakes like the night capital, as I told, for example, some code going to production without a code review. So, and this is very common in the places that the machine learning operations are run by guys that don't have any kind of background in software engineering, for instance. Another challenge, for example, bias. So if your algorithm do some kind of decision that takes into consideration some structural bias, for example, race, for example, sex, gender, for example, sex, gender, or for instance, religion, for example. So your company can be scrutinized by public opinion because of that. And so on, so on, so on. So I think this is basically would be the biggest challenge for that machine learning systems are bringing to the table. And on top of that, we are having right now at this time that we are speaking right now, several different bodies of legislators, of congressmen, congresswomen, trying to figure out how to regulate those systems. Because one thing is that when we talk about, for example, some kind of scoring script that do some kind of scoring that it's not related with this business itself, or some kind of recommendations in the very item based or something like this. But another thing is when you do some kind of real scoring that you have people doing critical decisions, or critical decisions being made by some algorithm that defines the future of someone. For example, one single example of this, for example, YouTube, that do some kind of problems in terms of radicalization, let's put it that way. The company was completely scrutinized. So your company is prepared to that, for example? If yes, so you can continue using that. If not, for example, you should be concerned about this new challenge of this that machine learning problems bring to the tables right now for companies.
Yeah, totally. And yeah, dealing with data it's a tricky subject. If anyone else has any other questions, I got one last one. It looks like we're almost finished up. But if someone else, I want to open it up to the field in case someone has a question, because I know I've been talking a lot. I'm wondering, you've painted this picture for us. Do you feel there are tools that can help to make things easier for you, and how would you recommend using them?
Yeah, absolutely. So I will share with the guys that are actually watching right now, but I'll tell for the guys that are only listening. So basically, if I need to define on some tools that can help in terms of machine learning operations, I can define in the 5 different aspects. Orchestration, so the way that you coordinate your data flows, or the way that things are processed inside of a machine learning pipeline, or the way that you coordinate your training and your data at the same time. That we can, for example, Airflow, Apache Mesos we do that, or Kubeflow, that it's a very great tool to do this. Observability, so in terms of how to keep these traces, logs, monitoring. So I recommend for sure Elasticsearch, Kibana, Prometheus. So Prometheus is I think they are developing some new tools for machine learning, I guess. Grafana, Sentry for error tracing and so on. FluteBeat, Datadog. But Datadog, it's more related with the systems itself, so system metrics. But you can adapt some metrics that you can use as application performance management, for instance, like diversity of items in some kind of recommender systems. Another point, it's in terms of experiment management. So this is one of the topics that is completely different from the software engineering, and mostly of the data science community are not talking at all. So how to make the experiments reproducible, for instance, and how you can track that. So let's say that if you need to do some kind of holdback in the model right now, so how you're going to do this, or if you need to retrain your model, for instance. So, and we have some tools to do that. For example, ModelChimp, Forge, Datmo, StudioML, Sacred, MLflow, and Polylexical, for example. It's one example, some examples of this machine learning experiment management.
Yeah, and if anybody wants to dive deeper into that, the experiment management, the first talk that we did for the MLOps community, Luke goes into that in depth.
Yeah, absolutely. Another topic that, as Luke told in one of his talks, it's a completely different topic from, for example, for the software engineering and from infrastructure. Of course, it's data versioning and data management, for example. That because right now the ways that we do that, most of the time someone just cut some data set and freeze the data set and push some kind of S3, and someone needs to recall the S3 link to download the data and run the experiments. Or if the company just have this concern, because most of the time people don't have this kind of concern at all. And there are some tools to make this kind of data versioning, like DVC, like Pachyderm and Snorkel. For example, Snorkel, it's more about the data labeling, but you can use to do some kind of data management in terms of the labeling of your data. And least but not less important, we have right now several different machine learning software as a service that basically can do some kind of applications end to end, some SIMs, fetch the data from your database or your S3 bucket or Google Cloud Services bucket with your data, for example, BigQuery, for instance, until the model being production that you have your REST API with all the observability, for example, logs, monitoring, and so on. So some examples of that can be, for example, .science, IO, for example, Databricks, Algorithmia, Google AI Platform, SageMaker, .science also, Domino AI, Weights and Biases, Gradient, Paperspace, A2O AI, and Neptune AI, just to comment, of course, to say in a very few examples. So we have, and again, this is a very great time to be inside of the machine learning operations, at least in terms of tooling, because at the time that we see there's some tools that we can actually do the job. At the same time, I see that people of the DevOps are not aware of these tools. People of data science are not aware of these tools. People of infrastructure are not aware of these tools itself. So, and I think it's a very great opportunity for everyone that are actually currently working machine learning to go to machine learning operations. Because again, it's not about to put things in production anymore. So this era, I think it's over. Right now, how to put things in production and how make this applications reliable and traceable, and yeah, so I think this are the tools that can help in that task.
Completely. And one last question from Jay here in the chat. He's asking what your opinion on workflow engines is, replacing Airflow or replacing something like Airflow. Do you have any experience with that?
Yeah, of course. Yeah, I mean, not replacing Airflow itself, but I replaced Jenkins through the Airflow because basically this is one of the cases of data integration. So I don't know if we have more time, but I will talk anyways. So basically, we used to make all the orchestration inside of the Jenkins. So basically, it was some kind of bash script that runs some SQL that extract the data from the database, open the connection of the database, dump the data in some kind of CSV file, and then push the CS file to the S3, for example. In Jenkins, there are some problems in terms of orchestration, how to make this pipeline, make this kind of dependency tree along the steps. And at the second, the pipelines of the Jenkins are not so transparent for us in terms of code. So we just put inside of the Jenkins, they just pray to work. And if something goes bad, we don't know, for example, which processes are in jeopardizing because of the error inside of Jenkins, and we move to the Airflow. I think in terms of orchestration, I don't have much to complain about Airflow. I think it's a very good tool to do this. But my concerns about the Airflow, I think Airflow is too much over-engineered in terms of simple things that you can do. I mean, a small disclaimer, I used to work with the Microsoft stack for a long time in my career. And for example, some things that are completely transparent and super easy to do, for example, in the SQL agents, for example, just to schedule a job in some period of time and put this job in the code, for example, and then make sure that this job are going to run. Airflow with their, especially their database connections are quite hacky in some way, and especially if you're using with the salary executor, you cannot do some kind of some kind of real orchestration, just for example, speed up several different processes at the same time and hope then to execute in parallel. So we have some problems on that, especially if you're using it with the Kubernetes. But I mean, just to make more clear my point, I mean, I like Airflow, but I think Airflow is a quite over engineering that aspect. So I recommend for sure to use the Airflow, but using very straightforward DAGs, you know, like if you need to use several different connectors, or if you have a very complex dependence tree in terms of orchestration, so maybe you can find some hassle to use Airflow.
Great. Well, looks like that's all we got for today. Flavio, big thank you for coming and joining us and explaining about all of this and dropping some knowledge on us.